So I want to make sure we have this in our notes here. Find the equation of the line that's tangent to the graph of x cubed plus 2 and parallel to the line 3x minus y minus 4 equals 0. So this is, a lot of the stuff that we start with is going to be just a bunch of review from algebra. If I am wanting to find the equation of a line and make sure we understand what we're looking for the equation of a line. What information do I need? One more time, Sean K. The gradient. Now, what's another word for gradient? Slope. And we need the slope. I'm putting the word "the" in there to remind us that there's only one slope of a line. And we need a point. We don't care what point it is. We just need a point that's on the line. Now, if I want the equation, I want the tangent to this graph to be parallel to this line, which of these two bits of information am I going to get from this? The slope. Okay. So we're going to take the slope from here, and I can only do that if I write it in another format. This is an equation of a line, but I need another format for it in order to really tell me what the slope is. So, Peter, what do we need here?
You add 1 to the other side.
Okay. So we have y equals?
3x minus 4.
Okay. And the fact that our line is parallel to this line, lines are parallel when they have the same slope, so the slope of this line is 3. What slope are we going to use for our line? 3 again. Okay. The fact that I know that I need a slope of 3 now is good, but it's not sufficient. Okay. So I need to do what now? I want this a line that's tangent to the curve of this. So I need to find what of this function? Yeah, I need a point, but I know the slope of the tangent is going to be 3, but what do I have to do? How am I going to proceed? What input values? I don't think so. Let's go to our inspires. Let's see what we've got here. Go to a new document. We're going to add a graph. And what was this? X cubed plus 2. So x cubed plus 2. Okay, there's our function. I'm going to change the window. I don't think I need all that. So I'm going to make this negative 5. I'm going to try it to 5. I'm going to scale it by 1. Oh, we might as well make this. Now let's make it negative 3 to 3. I'm guessing. If I'm wrong, I'll go back and. Oops, then we need to make that negative. There we go. Okay, I don't like all this work down here. I'm going to do a little more work with that. And at some point I'm going to walk back there so I can see it better. So I'm just going to finesse this just a little bit more. Looks like maybe I can get by with this, negative 1. Now let's see what that looks like. That's a little better. And a control G is going to take away that entry line. Okay, so there's my function. I need to know where on this function I'm going to have points, a point that has a tangent that has a slope of what? 3. Okay. So you said put a value into x into f of x. I don't have a clue where to start. Okay. I could do a bunch of guessing on this. I could put a point and then put a slope and then just try to maneuver that point to where the slope is coming up to be 3, but frankly that's estimating. Okay. Let's get to be exact. So the exact way to do our work is always going to be the analytical approach. Analytically, how can I get from here to something that will also describe a slope? I had one response. I don't know if you heard her. Sean Kay's given up both of her answers that she is allowed to give us today. Well, let me ask you, on your paper, go down a ways or whatever, I want you to write the definition of a derivative. Write it out, please. A derivative is. I was. Thank you. Okay. Did you get all that? Okay. So we've got then the limit process here, and so what? Okay. So the so what says we're going to start here. I want you to write the numerator of that. Okay, let's start to build this. Megan, what's the first thing we're going to write in this numerator? Okay, stop right there. X plus delta x. Quantity, you said cubed? Okay, I'll continue. That's a 3 up there. There you go. We'll make it a 3. Thank you. Continue.
Oh, sorry.
I have x plus delta x quantity cubed plus 2. Okay. Now, let's see. Lauren, what's the next piece? Y plus. Minus. Okay. Minus x cubed plus 2, just like that. Thank you very much, because if you don't put those in, you're going to forget to distribute that. Divided by delta x. Okay? When we get that far, we're going to have the limit. Delta x approaches 0. Now, this is where you pick up your inspires. If you don't know how to cube a binomial, you pick up your inspires and let the inspire help you out with that. Do I need to show you where on the inspire and how to do it? Okay, we'll do that. Jordan, you got a question?
Yeah, I do. For the first part, when we substitute the function as the first part of the limit, is it always just add delta x whenever there's an x? Is it always?
Okay, what does this say right here?
X
What?
delta x?
Okay, and this is my input expression. So yes.
Okay.
Yeah, absolutely.
Whenever there's an x in the function, you just add a delta x.
If I gave you this, what would you do with it? Everywhere you saw an x, you'd put a 4. Same thing. Okay? Absolutely the same thing. You know, and this is what is truly not understood by a lot of the teachers out there, is that we as students don't always understand what they go through. You've known forever that f of 4 would mean every place you see the input, you put that, but we somehow forget that this is an input also. That's why I'm so specific when we start this course. I'm so specific in calling that the input, okay? Because that is exactly the same thing we do. Okay, so we know that now, and let's go on here. Again, if you don't know how to cube a binomial, don't worry about it. Let's just go in here. I'm going to do control on the document, pick up a calculator page. So those of you, I'm working on this model today. How about those of you with the click pad? You okay? You know how to, you go home and pick that up? Okay. Menu. Algebra. Expand. Menu. Algebra. Expand. What are we going to expand? Well, we're going to expand parentheses, so make sure you put a parentheses in there. And we've got x, what was that, x plus 2? Well, we do have delta x, I agree. Okay, let's do it this way then. I'm going to back that up. Let's make it x plus h. Where's the h? Is that h? Yeah. Let's make it x, because we can't put delta x in there. And you've got to have that middle set of parentheses in there because you're going to raise this to the third power. The parentheses come with the expand, okay? Once you're inside the expand function or the command, you then have to write it exactly as you want it, and this involves using parentheses. If we press enter, do we get something equivalent? And instead of h, you're going to put, okay. That's how we can use that. So I'm going to go back here, and this would be x cubed plus 3 x squared delta x plus 3x delta x squared plus delta x cubed plus 2. And I'm working in the numerator here. Now can I distribute the negative? I think I can. At this point, what must happen? What? Cancel what? Every term that does not have what in it? Okay, it has to be that way. Every term. Why does every term without the delta x have to cancel? Absolutely. We can't use direct substitution as long as we have this denominator that would be 0. So we have to be able to factor out a delta x. So I've got the limit. Delta x goes to 0. I can now factor out a delta x. Then and only then do I have a factor in the numerator to cancel with the factor in the denominator. I have to be able to have that factor. If I have a term up here that doesn't have delta x in it, I can't factor out a delta x if it doesn't have it in it. Okay, at this point, is there any more work we can do? Danielle, what would it be?
Put in 0 for delta.
Yes. And our answer is 3x squared. Now, I thought you told me that what I was going to get when I did all this process was the slope value, the slope of a line tangent to the curve at a point. That's not a value yet. Okay? Can we stop this? Is that what you're saying?